So here was what I'd like you to do. First of all, what is a binomial? What is a binomial? Anybody know? Yep.
X plus 1 times x plus 2. Two terms.
This is a binomial, right? It is a mathematical expression that...
It's recording.
It's a mathematical expression that has two terms in it. In this case, the x and the y, a binomial. Mathematical expression with two terms. Bi means two things, right? So I have x plus y. Now, here's what we're going to do. If I'm going to raise this to the power of 0, tell me what all of that is going to equal. 1. Very good. A 1. You guys are on board. Okay, now, there we go. X plus y. If I raise this to the power of the first, what am I going to get out of this?
1.
No, I'm not going to get 1. I'm going to get x plus y. Very good. You guys are on board so far. All right, this is another binomial, x plus y. I'm going to take this, I'm going to raise it to the power of 2. What would I get?
X plus 2xy plus y squared.
Say again?
X squared plus 2xy plus y squared.
X squared plus 2xy plus y squared. That's true. Okay, we'll do one more. If I do x plus y and I raise it all to the third power, go ahead and tell me what you would get. Simplify your expression as far as you can. All right, Parker, tell us what you got, buddy.
X cubed.
X cubed, yes.
Plus 3x squared y.
Plus 3x squared y.
Plus 3xy squared.
3xy squared.
Plus y.
Plus y to the cube. Okay, now, would you say that that was somewhat challenging to get?
Yeah.
Or I wouldn't say challenging, but it was time consuming, right? Okay. So how many of you took the previous term and then just multiplied it by an x plus y? Is that what you guys did? Yeah. All right, good. That's a really good strategy. Now, let's talk about this. This is the exploration part, all right? In the 0 exponent, all right, so for the 0 exponent, how many terms ended up being present? Huh?
1.
Good. For my exponent of a 1, how many terms ended up being present? 2. For the exponent of a 2, how many exponents? How about for the 3? Okay, so if I kept going here, and I did x plus y all to the nth, how many terms am I going to have? Yeah, n plus 1 total terms, right? Okay. All right, so if I asked you to say, I don't know, something like x plus y all to the 12th, that would be a pain in the butt to sort of expand all the way out. Wouldn't you agree? That would take a long time, right? It'd be nice if there was a more sophisticated way that we could get this, and it turns out there is. And that's what we're going to learn how to do today. We're going to learn how to expand these things, okay? All right, but before we do, here's what we do. There should be a highlighter somewhere in your jar, okay? And what I would like you to do is I would like you to highlight, okay? Sparse jar over there, okay? I would like you to highlight all of the coefficients. Highlight all the coefficients in front of your terms, okay? So for an example, if there's one there, this would be a 1, there'd be a 1 there, that would be a 1, there's a 2 there, that'd be a 1, that's a 1, and then 1. Highlight all those for me. All right, in learning how to expand using the binomial theorem, one thing we have to learn is how to get these coefficients, okay? So I'm going to introduce to you the choose formula. And there's two ways to represent this choose formula. It could either be n over r, or it could be NCR. So what we're going to have here, n over r or NCR, it's represented both ways for us.
Is there not a line? Is it not?
No, there's no line. It's just an n and then an r right there. Yep. So it is n factorial over r factorial times n minus r factorial. Okay. What this does for you, this actually comes from our probability, okay? This is actually a way to choose. It's called the choose formula, n choose r. It's supposed to be n objects taken r at a time. But what this also does, it gives us a binomial coefficient. So for us, this is the binomial coefficient for expanding. Okay? That'll give us the binomial coefficient for expanding. It's this thing right here, which comes up again in probability and statistics. So let me just give you an example of what this means. So let's say we have 10 over 3. Now the book uses the term over. You'll hear me use the term 10 choose 3. Okay? So what this actually means is 10 factorial all divided by 3 factorial times 10 minus 3 factorial. Or just 10 factorial over 3 factorial times 7 factorial. Okay, go ahead and tell me what that number is. You can use your calculator, and then I'll show you where the button is. Okay, how many people got this? 10 over 3 factorial, 7 factorial? 120. Okay, and that's how I did it right there. You can see in the calculator that's how I did it. Okay, if you do 10 factorial divided by 3 factorial times 7 factorial, it'll take the 10 over 3 first, and then multiply that by 7. That's not what you want to do. You want to keep the denominator as a single number. There's a much easier, faster way to do it, okay? And this is why I put a C here to remind you that if I want to take 10 over 3, this again, this gives me the binomial coefficient for expanding, it would be 10. Go to your math button, go to your probability button, and check out option 3 instead of 4. And check it out. And then plug in a 3, and bam, you get the same thing. Way easier. Let's all agree to use that one instead.
Whoa.
For example, if we want to do 23 choose 17, we're going to go 23, we're going to go math, we're going to go probability, option number 3, and then 17. And we're all agreeing that we're getting 100,947. Okay, we have 2 special cases that we're going to talk about right now. N choose 0 and then N choose N. So really what this is saying is this is a way to combine objects. As an example, all right? So let's say you have 5 pens in a drawer, all right? And we want to choose like 3 of them. How many ways can we combine 3 of them? That would be 5, choose 3. And that formula would tell us the total number of ways we could actually combine 3 of those 5 pens, okay?
Is that a 0 or 1?
That's a 0, right?
Sorry.
That's a 0. Now, there are 2 special cases, all right? This is N choose 0, and this is N choose N. So we're thinking N choose N. Yeah, choose. C stands for choose.
Wouldn't it just be 1?
Yeah, both of these cases would actually just be 1. And the reason is because what this question is asking right here is how many ways can we choose none or no option at all? And there is one way to do it by just saying, I'm not going to choose. That's the one way, okay? Same logic goes for, let's say I have 10 pens in a drawer. How many ways can I pick all 10 of them? Well, there's only one way that can happen, by grabbing all of them and then walking away. So N choose N is 1, and N choose 0 is also 1. So there's one way to choose nothing, and there's one way to choose everything. Those are my 2 favorites.
Can you take some and leave some?
Yeah, that'd be 10 choose 7. That'd be different.
Okay.
Yeah. All right, Pascal's triangle. This is hanging out outside in the hallway, I think next door. Who's ever seen this before besides on that poster down the hall? No one? A bunch of times? Okay, what's going on here? How did we get this? Yeah, hold on.
Isn't it like, okay, well, I only know like from the 3rd
Okay.
row.
Yep.
It's like 1 and 2, and then below it is 3.
So where does this 3 come from?
The 1 and 2 above.
It comes from adding 1 and 2 together to get the 3. You guys agree with that?
Yeah.
Where does this 4 come from?
From the 3 and the 1.
It comes from adding this 3 and the 1 together. You guys agree with that part? So I'm wondering then, could you guys maybe help me then write out the next line? It would be 1, then what? 5, then what?
10.
Then 10, then what?
10.
Another 10, then what? 5, and then finally what? 1. Okay, now take a look at these. And you remember what I asked you to do in the very, very first box? I asked you to highlight something. Coefficients. There is a connection between Pascal's triangle and the coefficients when we expand a binomial. I'm wondering if you see it.
Yeah.
Okay, Griffin, tell me what you see, buddy.
Each, so like if the exponent in the binomials, let's say it's like 2, then the coefficients will be 1, 2, 1.
Very good. So check this out. If I had x plus y to the 0, what was the answer, you guys? The answer was 1. When we did x plus y to the first, what was the answer? It was x plus y. And can you guys tell me, what are the coefficients in front of my x and the y? A 1 and a 1. Anybody see something building here? Okay. It is Pascal's triangle. What if I asked you to do this? X plus y to the what power? To the second power, right? And then you guys told me that it was what? X plus 2xy plus y. Oh yeah, scored, thank you. And then can you tell me, do you see Pascal's triangle? A 1, a a 2, and a 1. Do you guys see Pascal's triangle? Okay, so let's do one more. I asked you then to tell me what was x plus y to the third. You guys told me it was x to the third plus 3x squared y plus 3xy squared plus y to the third. And you'll notice that there's the 1, there's the 3, there's the 3, and there's the 1. Do you see the connection between the two? All right. There's another connection to all of this, all right? There is another way that you can actually get a 1. And the way that you get the 1 is this is the 0 exponent, right? What do you guys think 1 choose 0 is?
1.
It's 1. Okay. What do you think 1 or this is 1 choose 0. What choose 0 is 1? What do you think 1 choose 1 is?
1.
Yep. Okay. Now I'm on the second exponent. What do you think 2 choose 0 is?
1.
What do you think 2 choose 1 is?
2.
And what do you think 2 choose 2 is?
1.
Yeah, okay. Now I'm on the third exponent. What do you think 3 choose 0 is?
3.
Well, it's 1. What do you think 3 choose 1 is? What do you think 3 choose 2 is? And what do you think 3 choose 3 is? So notice that those 1s are taking up the ends of our pyramid, right? So because there's 0, there's one way to choose nothing, and there's one way to choose everything. So there are two ways in which we can actually get these binomial coefficients. We can either use Pascal's triangle and write them out, or we could take advantage of the fact that that binomial coefficient formula will give us the exact same thing that Pascal's triangle does. It's pretty amazing that that works out. So to drive this point home, 1 is the same value as 4 choose 0. Now, why am I using the 4 here? Because this is the fourth expansion, x plus y to the power of 4. 4 choose 0, 4 choose 1, 4 choose 2 is a value of 6, 4 choose 3, a value of 4, and 4 choose 4, a value of 1, and so on, okay? So we are now all set up to really start to understand this binomial theorem. All right, if we're going to expand a binomial x plus a all to the nth power, all right, it will be, we will start with the binomial coefficient. It will be n choose 0 times x to the nth times a to the 0. Okay? So let's talk about what we see here. And you've actually seen this, you just don't know it up above, okay? This right here represents all of the very first term, okay? The very next term, a sub 2, is going to be, we're going to have n choose 1. We're going to go x to the n minus 1, a to the 1. So what's really going on here is that, and then we keep going all the way down. We add these together and keep going all the way down until we reach n choose n, x to the 0, and then a to the n.
Shouldn't there be a plus sign? Just
Yep,
wondering.
right there. Now, how many total terms are going to be when I expand this? Remember, what's the exponent here? There will be n plus 1 total terms. So here's what's really going on, all right? We're starting with our exponent, and we are writing our choose formula from 0, and we are increasing until we get to n choose n. That's what we're doing. That will give us our coefficient. Then we take our very first term, which in this case happens to be x, and notice we start with an x to the n, and we go down by 1 until we get to x to the 0. And then likewise, we start with the very second term, in this case is a, and we start with 0, and we go in the reverse order until we get all the way up to a to the n. So we just did this up at the top there. I'll let you guys write that down, and then I'll show you an example. All right, would you first of all agree that if I asked you to tell me what x plus y to the 6th power, would that take you a bit of time to do? That would be very, very laborious, right? And it would not be very, very exciting. Let's use the binomial theorem instead, okay? First of all, I have an x plus y to the 6th. What's my exponent I'm dealing with here? 6. So how many total terms will I have?
5.
No, other way. 7. So here's what I want you to do. Make your 7 terms. First term, second term, third term, 4, 5, 6, and then 7. So give yourself 7 terms. There will be 7 total terms. I'm going to shrink this down a little bit so I can fit it on there. There we go. Okay, we're going to start with our binomial coefficients first. So we're going to start with 6 choose 0. And we're going to work our way all the way up until we get to what, everybody? 6 choose 6. Very good. 6 choose 1. 6 choose 2. I heard that, by the way. 6 choose 3. 6 choose 4. 6 choose 5. And then 6 choose 6. Okay? Don't write it as a fraction. Then we take our very first term, which I'll do in green for you. Our first term is x. We're going to raise that power to the power that we were given, x to the 6th. Then we're going to reduce that power by 1 until we get down to what? X to the 0. So that'd be x to the 5, x to the 4th, x to the 3rd, x squared, x to the 1st, and finally x to the 0. Okay? Easy enough so far? Okay? Then we'll take our second term, in this case happens to be y, so we'll use purple for this. And we start with 0 and go the other way. Y to the 1st, y squared, y to the 3rd, y to the 4th, y to the 5th, and finally a y to the 6th.
Is this how it is with the y's and the x's all the time?
Yeah, this is what it is. This is applying the binomial theorem. And lastly, we take a look at the sign between the x and the y. It's positive, therefore we add between all of these. Okay? This right here, this is called what I call the setup. That's your setup. No. There's the setup phase, and then there is the cleanup phase. So we're going to actually go clean this up now, okay? So we actually have to compute all of these. So what is 6 choose 0? We know that one already. Yeah, that one's a value of 1, right? So all we're left with, so we'll go ahead and use pink. So this entire term becomes what? Let's see here. 6 choose 0 is 1. Y to the 0 is 1, so this just becomes what? X to the 6th. Good, I'm done with that one. All right? What's 6 choose 1?
1.
No, do we have it? Did we do it back up here? No, we haven't done it yet. 6 choose 1. Go ahead and figure it out.
It's always over 1, then it's 1.
Yeah, it's going to be 6. So I have plus, I have 6, x to the 5th, y. That one's done.
But I thought whenever it's over 1, it's always 1. That was
No, that's 0 and itself, okay?
Oh.
What's 6 choose 2?
15.
Okay, 15. This is going to be plus 15, x to the 4th, y squared. How do we know that? Because we know that 6 choose 2. Here we go. Here we go. 6 math option over option 3. And then we want 2 is a value of 15. There it is right there. Okay? What's this one going to be? This is going to be 20 x to the 3rd, y to the 3rd. Done with that one, done with that one. What's this one going to be?
15.
Yep. A positive 15 x squared y to the 4th. Done with that one. Plus, what's 6 choose 5?
6.
Very good. X, y to the 5th. Done with that one. And finally, what do I have for the last one? 6 choose 6 is just 1. So I have a positive y to the 6th. And that is the answer. Okay, this problem comes with 2 warnings, if you didn't see the big warning sign. Okay? It comes with 2 warnings, all right? First, what do you think one of the warnings is? Take a guess. What's that? Yes, there's a coefficient and there's a negative sign, all right? Very good. We're going to build this the exact same way, all right? But I'm going to show you where the common mistakes are and make sure that you do not make those mistakes. Let's start with what we know. What's my exponent, ladies and gentlemen? 4. And how many terms will I have total? 5. So let's set those terms up, please. 1, 2, 3, 4. I will have 5 total terms. Okay? I start with my binomial coefficients. So I'm going to have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and finally 4 choose 4. Easy enough, right? Okay, here's one of the warnings, and I'll do this in pink for you. You need to take the entire first term, which is 2x, and raise all of the 2x to the power of 4. What do you think the mistake that is most commonly made?
To distribute the 4 to each, the 2 and the x.
Yeah, people forget to raise the power of 2. Raise 2 to the power of 4 as well. So you have to raise the whole thing. So this is going to be 2x all to the third. This is going to be 2x all to the second. This will be 2x all to the first. And this will be 2x all to the 0, which of course is 1. But I'm writing it in there for the sake of being consistent. So I'll move this up so that everybody can see in the back. Okay? Then we take, and then we go y. I'll do this in green so you can see it. So y to the 0, y to the first, y squared, y to the third, and then finally y to the fourth. The second warning comes in the fact that there's a minus sign between them. If there's a minus sign between the binomials and your first term is positive, then your first term out front will be positive. And the signs alternate. So positive, negative, positive, negative, positive. That's it. You don't have to worry about the signs anymore. So those are the two warnings. That's the setup phase, and let's do the cleanup phase. All right? So if 4 choose 0, how much is that, you guys?
1.
That's 1. What's 2x all to the fourth power? No.
16x.
There you go. 16x to the fourth power. Done with that one, okay? What's 4 choose 1? 4. What's 2x to the third? 8x to the third. What's 8x to the third times 4? 32. X to the third y. Done with that one. Okay, what's 4 choose 2? 4 choose 2 is 6. What's 2x squared? 4x squared. What's 6 times 4x squared? So positive 24x squared. But I also have a y squared in there, so don't forget that one. Okay, what's 4 choose 3? 4 times 2x. A negative 8x y to the third. Done with that one. And then 4 choose 4? 1. Very good. Times 1 times a y to the fourth will just give me a y to the fourth. And that's the answer. So if you're given x plus 3 all to the 12th, what will the binomial coefficient be for the x to the 5th term? Okay, so to understand what they're asking us here is we're going to build our first term. First of all, how many terms will there be total? No, there'll be 13. That's a lot of terms to deal with, right? So let's go ahead and build. What would be the very first term? Well, it would be 12 choose 0. It would be x to the 12th, and it would be 3 to the 0. You guys agree with that?
Yeah.
Okay, that's the first term. What's the exponent on the x right now? It's a 12, right? What do we want? Because it says right here x plus 3 to the 12th. Okay. So which one do we want, you guys? Yeah, okay, so we want, it's going to be 12 choose something. The x needs to be a 5. That means that 3 needs to be a what power? Nope. No, it has to add a 12. 7. Yeah, this has to be a 7. So that means a 7 has to be there. And that means that we are finding the 8th term. All right?
Where'd you get the 7? Yeah,
Okay. Remember how I told you in the very beginning? This number and these two numbers need to add up to each other. Right?
Yeah.
And I also told you that the second term and the bottom one will always be the same.
Oh, yeah.
So if I know that this is a 5, then that means that what has to add up to give me a 12? 7, and that has to be a 7 down there. That's where it comes into play. So then all I do is figure out what's 12 choose 7. It would be 12 math over choose 7. That would give me 792. So this is pen. This is 792. X to the 5th. What is 3 to the 7th power? 2,187. So I multiply that by 2,187. And I get a number that looks like this. Times 792. I'm getting 132,000.
1,232,000.
That's what I got to. Yep, I got 1,732,104 x to the 5th. Therefore, that is the binomial coefficient.